I want to talk to you about all things Raspberry Pi clusters today. What I'm going to do is start off by talking to you about the BitScope Blade. Now, the BitScope Blade is made in Australia. It's manufactured by Bruce, and this is the 20 edition. This can take 20 Raspberry Pis. I've actually been told that you can squeeze 30 in, and it comes with this nice acrylic on the front. Now, if we get the cluster and have a closer look at it, we see it has a very sturdy frame around it, and right up top I have a switch. Now, the reason that I'm showing you from that point of view is because I just don't know what to do with the cables, and maybe Bruce and BitScope have some ideas about that. What we have is Raspberry Pis in groups of 2 that attach to power distribution boards. So I can show you that because I have the component parts here. Now, when this was actually sent to me from Australia, it got broke in transit. Some people were a bit heavy-handed. Now, this is what broke off, is these individual terminals. Now, you have a red and a black, and they sit opposite each other. Now, the power supply puts power through this, and then your Raspberry Pis mount on what are called blades. So we have 15 blades in this. The blades come in a duo or quad format. This is the duo, and as you can see, they have a 40-pin header on either side, and then you can either plug these in separately or they can mount within the rack. Now, when I resoldered it, I had a bit of trouble because I needed to get a screwdriver right into the top of here for each blade. And it's very tight, very hard to work in, but once it's put together, it is very strong. Now, I have a Raspberry Pi 3 here, and I can just show you how this fits together. This is very neat. The pins line up and we push it down. At that point, we have quite a solid unit, and all of the ports are exactly where you'd expect them to be. You do lose your headers because the headers are used to power the board, but usually I think for this kind of construction we only care about Ethernet. We have USB as well, so if you do want to take something like a Pi drive from Western Digital, you could plug that in as well and maybe find somewhere to put it within the cluster. Now, when you have that Raspberry Pi, you notice the SD card at the top. So if we had a cluster with 30 Raspberry Pis, we're going to be spending about $500. Now, those SD cards may start to become corrupt over time as we continually write to them in the cluster, and that might mean we continually having to pay that amount of money out. The alternative is to net boot the Raspberry Pi. That's where we get rid of the SD cards, we have one server, and that contains a file system for the Pis. Now, I tried that over Christmas and I shared a blog about that, and unfortunately it wasn't very reliable and there's still a lot of issues to iron out. So I think that's a very interesting space, and it will probably develop to the point where you can reliably net boot. Now, while we're here, let's talk about some smaller cluster ideas. Now, we can go to the opposite end and take something like the Raspberry Pi Zero. So you see here I've got 3 zeros, and they're mounted with tiny screws, which is a great way to build these on a budget. But I really wouldn't advise using Wi-Fi. These need to be far apart. They cannot really be a centimetre from each other. It may work initially, but you're going to get a lot of interference. The way I do it is with these Ethernet adapters. And so it does become a bit more chunky when these are placed off the back, but it works. Now, the one that I would recommend you buy has 2 LEDs on it. There's one available on eBay with a single LED, and it just doesn't work. So don't waste your money. Now, I'm not really using the zeros anymore because they cannot run Kubernetes, and Kubernetes is quite important for me. Kubernetes needs a gigabyte of RAM just to run on a node, and these, well, they only have 512 and a single core. So that means that the cluster hat is also out. Now the cluster hat is a very interesting product. This is a 4-port hub, USB hub, that sits on top of your Raspberry Pi, and then you can plug individual Pis, zeros, into it. A bridge network can then be set up where all of those zeros are accessible on the main Pi. So in effect, you have 4 cores and another 4 underneath. But the problem is that we have a different architecture on both. The zeros are ARM v6 and the main board is ARM v7. Now, architecture is a problem with ARM at the moment. There's very limited support for 64-bit ARM with something like this ROC 64. Now this has very good specs. I think it even has 4 gigs of RAM on there, but you find problems with Docker and Kubernetes when you come to 64-bit ARM. And so really, I think if you want to build a cluster, and like me, you have very limited time and this is just a hobby, you want to go for the Pi 2 or the Pi 3. It has very good support in the kernel, Docker and Kubernetes work, and there's lots of people that are solving the problems that you're going to come up with. So that's a summary of my clustering, and I just want to show you this once more. This is quite a significant piece of machinery, and it has a brilliant power supply that can supply over 150 watts. It's a very chunky piece of equipment here, and reliable too. Now I think this is probably quite a high efficiency adapter, because when I plugged in the 24 Raspberry Pis, I used a kilowatt and it was only measuring at 24 watts, which is very, very little. You're barely going to notice that. So if you're interested in building a cluster or finding out more about the BitScope product line, get in touch with me and follow the links below. You'll be able to set up your own cluster with something useful, and please feel free to ask me any questions. So here's the BitScope 20, the Blade, the cluster hat, the Zero cluster, a 2 gig Tinker board, and my original cluster. Thank you.